Write an argument that would convince a skeptic that your conjecture is true. Okay, so let's look at, not this one, this one. Given a triangle, prove that a line that intersects two sides and is parallel to the third side creates similar triangles and therefore splits the other two sides proportionally. Okay, so let's start with our diagram. We got the same diagram that we were looking at earlier. Line MN is parallel to AC because, let's look down here at the word bank. How do I know that those lines are parallel? This information is given. So I used this one. I'll do this in red actually. Okay, the next one. Angles BMN, so that's this angle, and BAC, that's this angle, are something formed by parallel lines intersected by the transversal something. Okay, so I know I have parallel lines and both of these angles are in the same place, same relative position. So that is, which kind of angles are those? That's corresponding angles. So these are corresponding angles. Formed by parallel lines intersected by the transversal. Okay, so what's the name of the transversal? So if these lines right here are the parallel lines, then this one must be the transversal. So that's line BA. And I think I see, yes, I see BA right there. Okay, so the transversal is BA. Angles BMN. Okay, let's do this in blue. BMN is congruent to BAC by, oh, let's keep this in red, by, okay, so if these are corresponding angles, then the name of the theorem that tells us those angles are proportional, oh, it's the one that's capitalized, corresponding angles theorem. Okay, and now it looks like the next couple of steps look very similar to the previous couple of steps. So let's try this. Angles BNM, so that's this one, and BCA, so that's this one, are what kind of angles? Okay, so just like last time, because these angles are in the same relative position, they're both that way. So I think we would call these corresponding angles again. Corresponding angles formed by parallel lines intersected by the transversal. So if these are the two parallel lines, then that makes this line the transversal. So the name of that line is BC, and I think I see BC right there. Angles BNM is congruent. Angle BNM is congruent to angle BCA. So BNM, BCA, those are the corresponding angles. So the theorem that shows those angles are congruent would be corresponding angles theorem. Okay, so now because we have these angles congruent, we should be able to show that we have similar triangles. So let's see, triangle BMN. So that's this triangle. BNM is congruent to, oh, that should say similar to, sorry. Should say similar to. Triangle. So that would be the big triangle. There's the big triangle. And so if it's BMN, then it should be BAC. So this would be BAC. And then in this step, we proved that we had corresponding angles congruent. And in this step, we proved that we have corresponding angles congruent. So if I check my list of similarity theorems, I see it right there, angle, angle. So if two triangles are similar, then corresponding angles, okay, I remember this, corresponding angles are congruent. And corresponding sides are, I remember this one, proportional. Proportional. Okay, so from the similarity statement right here, we should be able to read off the proportions. So BM are the first two letters, BA are the next two letters. BN is the first and third letter, so that should be BC there. And then AC, these are the last two letters, so there should be the last two letters there, MN. And I do see BC right there, and I see MN right there. I'll do these in black. And there's the BAC that we used earlier. We used up everything in the word bank. All right, so here's our proof. We started out knowing that we had parallel lines. Because we had parallel lines, we got a couple of pairs of corresponding angles. Once we had the corresponding angles congruent, we used angle-angle similarity theorem. And then we showed that because the triangles are similar, that means we have corresponding angles congruent and corresponding sides proportional. And then we were able to fill in those missing side lengths to show that the parallel line divides or splits the other two sides proportionally.